In our pursuit for sustainability and innovation, Team 24094 presents the Mealworm Project, a breakthrough in trying to revolutionize fish feed production. Our objective is clear: providing a scalable mealworm-based fish feed that will not only meet but exceed market demand, as well as targeting 5% of the global market share. Our unique composition of 75% mealworms to 12.5% vegetable oil and 12.5% vitamins and minerals is our promise to you that we will ensure a high-quality, nutrition-packed fish meal.
Commercial fish meals currently available lack sufficient nutrients and proteins which are vital for the health and growth of aquatic species. To address this issue, an enhanced fish meal has been developed, providing higher levels of essential nutrients and proteins and ensuring better growth and health outcomes for aquaculture. This project seeks to develop a sustainable method for producing mealworms as an eco-friendly fish feed source tailored for general fish feed, with a focus on making it easily accessible. Objectives include identifying the optimal mealworm type and growth method, establishing a production process, designing systems for small-scale farmers and larger producers, and trying to maximize the production of the mealworms while minimizing the cost. For this project, the pieces of equipment that need to be used are the production unit, dehydrator, grinder, mixer, and final product storage tank. Based on the nature of this project as well as the equipment that we are using, we believe that Florida is the best place to start up this type of project. Once we figured out the location, it was time to create the process. We made a simple PFD showing the process going from mealworms all the way to exiting as a product. And this PFD is what we base our floor plan on. So now what would the process look like? From this floor plan that we have designed, we can see that we have 5 main sections: our production unit, our dehydrators, our grinders, our mixers, and our final product storage. That makes it so we have 5 steps that we need to go through in order to finish this process. So for our first step, it's the mealworm introduction to the product unit. On this floor plan, we have 30 production units, each capable of holding on to 45 kilograms of mealworms. So the process will look like introducing these mealworms into these production units for breeding and as well as growth. And we will be starting with approximately 1,340 kilograms of mealworms per batch, evenly distributed across the units, utilizing 110,000 kilograms of oats per batch to feed these mealworms within these production units. And we are hoping that by the end of the 90 days, we will be producing 108,000 kilograms of mealworms. Step 2 is our dehydration step. We have 2 pieces of equipment here, our dehydrators on this floor plan, that will dehydrate our grown mealworms for 68 hours to reduce their moisture content. By reducing the moisture content of these mealworms, we are hoping to have an easier time when placing these dried mealworms in our grinders. So these mealworms will be 40.44% lighter than their alive and moistured mealworms. So when we begin with our 108,000 kilograms of live mealworms from our production unit, that will result in us having 64,300 kilograms of mealworms post dehydration, since they are reducing in moisture content. So for the third step, after dehydrating the mealworms in our dehydrators, is moving on to the grinder phase. We will have all 3 grinders active for 6 hours in order to grind all 64,300 kilograms of our dehydrated mealworms into a fine powder to make the next step of mixing much easier. For our fourth step, we have our nutrient mixing step. So for this step, we have 15 mixers, each capable of holding 200 kilograms. So we'll be taking our ground mealworms, our 64,300 mealworm powder from our grinders, as well as 21,400 kilograms of supplements from our nutrient storage tanks, on putting them all into the mixers and mixing them for a total of 2 hours to get a combined total of 85,700 kilograms of fish feed. Our fifth and final step is the final product preparation step. We will be utilizing 32 storage boxes for final product containment. Each of these boxes can hold up to 2,700 kilograms in capacity. So the process is looking like moving all our mixed product from the mixers into our storage tanks prior to a customer pickup. The goal is to achieve and store 85,700 kilograms of the final product per batch. The final goal of this project is to try and get that 334,000 kilograms of fish feed produced yearly. That is what the results show, and that aligns with our goal of providing 5% of the global fish feed market. The team has developed a strategic logistics plan for the distribution of fish feed to farms, with a combination of direct delivery and third-party logistics partners to ensure timely and efficient shipment of fish boxes. The team will use refrigerated shipping for longer distances or warm climates to preserve the feed's nutritional value and quality, and to ensure that no harm is done to the fish feed while being transported. Moving on to the annual revenue, our project is expected to generate $2,660,000 each year. This robust revenue projection is based on our sales forecast and the current market demand for fish meal produced from mealworms. Now, looking at the break-even point, which is a crucial metric for any business, our project will reach its break-even point in the 4th month of operation. This means that within just 4 months, we will start to cover our initial costs and begin to make a profit, a testament to the project's financial viability and efficiency. Shifting gears to operational costs, we have annual labor costs sitting at $228,800 for 10 workers. This covers all employment expenses, including wages, benefits, and any other associated labor-related costs for our dedicated team, ensuring competitive salaries while maintaining a lean workforce. Our annual utility cost is forecasted at $84,000 based on the total kilowatt hours used and the current electricity rates in Florida. This accounts for all energy requirements across our operations, highlighting our commitment to energy efficiency and cost management. Lastly, the annual raw materials cost amount to $844,000. This includes all expenses related to sourcing the mealworms, their feed, and any other materials required in our production process. These costs are a reflection of our effort to source high-quality inputs to produce premium fish meal. To summarize, these figures not only showcase the project's profitability, but also emphasize our strategic focus on cost reduction and efficiency. Our rapid break-even timeline is an indicative of a robust business model set for sustainable growth and profitability. To round this project out, we are going to be using brewer's yeast, a byproduct from breweries, contributing to 1 million tons of waste a year, which will allow us to contribute to a more sustainable industry practice as well as utilize an underutilized resource.